So another concept involving related rates problem is we have if f if x squared plus y squared is equals to z squared, and we are given dx over dt is equals to 3 and the y dt is equals to 5. Find the x dt when x is equals to 8 and y is equals to 15. Since we are now given with x and y, so we are just going to find the z. To formulate that, we will use again the Pythagorean theorem, which is x squared plus y squared is equals to z squared. Substitute all the value we have. We are now in this part. 8 squared plus 15 squared is equals to z squared. Simplify. We have 8 squared is 64 plus 15 squared is 225. 64 plus 225 is 289. So the square root of 289 is 17. Since we now have the value of x, y, and z, we need to formulate the equation. This is our equation. We need to derive x squared plus y squared is equals to z squared into d over dt. So again, the derivatives of this equation is 2x times dx dt plus 2y dy dt is equals to 2z dz over dt. So next is we need to simplify or put all the values of the variable. 2x, our x is 8 times dx dt is equal to 3 plus 2 times y value is equal to 15 times the dy dt is 5 is equals to 2 times 17, which is the z value, and the unknown variable is dz over dt. Simplify this equation. We have 2 times 8 times 3 is equals to 48 plus 2 times 15 times 5 is equals to 150. So 40 is equals to 34 dz over dt. To simplify, 48 plus 150 is equals to 198 is equals to 34 dz over dt. And to solve for dz over dt, divide both sides by 34. So we now have the value of dz over dt, which is equal to 198 over 34, or it is just equal to 99 over 17. This is the value of our dz over dt. Gets? So let us move switch to the more realistic example on related rates problem. Example number 1. A ladder is 25 feet long, is leaning against a vertical wall. If the bottom of the ladder is peeled horizontally away from the wall at 3 feet per second, how fast is the top of the ladder sliding down the wall when the bottom is 15 feet from the wall? First is we need to illustrate our main problem. If this is the wall, if this is a ladder which is 25 feet long, and this is our wall, and this is the bottom of the ladder to the wall. We have the value of those dimensions, which is ladder is equals to 25, and the y, we label this as y and we label this as x. So we created a right triangle. Since we have the value of x, which is the ladder from the wall is 15. So we are looking for the value of y, meaning the distance over here. So to get that value, we will use Pythagorean theorem, so which is x squared plus y squared is equals to z squared. So this is the formula. X squared plus y squared is equals to 25 and our x is 15. 15 plus y squared is equals to 625. And y squared is equals to negative 225 plus 625. Negative 225 is just the square of 15. It became negative because I put it in the other side. And the square root of 400 or 200, negative 225 plus 625 is 400. The square root of 400 is 20. So the dimensions of this side is 20. So we now have the value of y. Since we have now the value of y, we will solve x squared plus y squared is equals to 25. And this is our main equation. So again, for next step is derive, multiply it to d over dt. X squared plus y squared is equals to 25 squared times d over dt. So the derivative of x squared is 2x times dx dt plus 2y dy dt is equals to 0 because it is a constant 25 squared. So substituting all the value, 2 times our x is 15 plus times our dx dt is equals to 3 plus 2 times our y is 20 and our dy dt is unknown is equals to 0. Since we are looking for the rate of change at this point, so simplify the value we have. 2 times 15 times 3 is 90 plus 2 times 20 is 4 times dy dt is equals to 0. Simplify to get the dy dt value, need to plus negative 90 to both sides. And we left with 40 dy dt is equals to negative 90. To get dy dt, divide both sides by 40. We left with dy dt is equals to negative 90 over 40 or negative 9 over 4. So it implies that the rate of change of this when the ladder is pulling down, the rate of change of this of the distance of y or the wall it is decreasing at a rate of 9.4 meter per second. It is negative because the area of the distance between at this point to the ladder is decreasing. So when this ladder is moving down, its distance is approaching to 0.